Hi everybody. So it's pretty obvious that we need a little bit of work here in trying to find areas for density functions to find probabilities, because everybody keeps missing those problems, and honestly it's just not that hard. So I think the biggest problem is that you're having issues with geometry. So let's take a look at some simple geometric shapes, and we can come up with some ideas on how to take care of these problems. So let me show you a couple of examples. The first thing that we could look at is one like what was on the test. We had a triangular density function. Let's just call this 5. Okay. The first question typically is, how high does it have to go? Okay, well, you know the area of this triangle has to be equal to 1. Well, the area of a triangle, you know, maybe you don't know. Well, now you do. Is 1/2 base times height. Okay? So all you got to do is plug in what you know. We know the base is 5. We're trying to find the height, and the area of the triangle has to be 1 in order for it to be a density function. So we just plug in what we know, and we find out 1 is equal to 5/2 h. If we divide both sides by 5/2, then we find out h is equal to 2/5. You can do all of this with fractions too if you want. It's fine. You can make that 0.5. 0.5 times 5 is, I'm sorry, 5 divided by 2, or 5 times 0.5 is equal to 2.5. So you know you can do it all with decimals too, and it'll work out just fine. So I'm going to go ahead and put that as 2/5. 2/5 is also 0.4, so it could also be 0.4 up there if you did it with a calculator. So we know that the triangle is 2/5 of a unit high. Okay, so now we might get a problem like this one. What's the probability that x is greater than or equal to 3? Okay, so here we go. There's 3. Greater than or equal to 3 means this area right here. Okay? And a couple of classes, and I forget which one, I gave you guys a hint. I said complement. Okay? I think that you would probably rather find the area of a triangle, because you already know that, than trying to find the area of a trapezoid. So if we're trying to find the area of the shaded region, let's find the area of the triangle and subtract it from 1. That'll give us the shaded region's area. So what we've got to do then is figure out how high does this go, because we need the height in figuring out the area of the triangle. Okay, in a triangle, it's just strictly proportional. Okay, the height has the same proportion to 3 as the height of the big triangle has to 5. And you could set that up as 2 fractions. Okay, let's call this h. So h units high. H units is to 3 as 0.4 is to 5. You could do 2/5 there too if you wanted. So if you've got this equation, all you have to do is cross multiply. 5h is equal to 1.2. h is equal to 1.2 divided by 5. And so if you figure out what 1.2 divided by 5 is, I'll get my calculator here, figure it out real quick. 1.2 divided by 5 is 0.24. So this is equal to 0.24. So this height is 0.24. If it's 0.24, now we can figure out what this area of the triangle is. So area of the triangle is equal to 1/2 base times height. Okay? And then if I can multiply all that out, 0.24 times 3 divided by 2 is 0.36. And so the probability of being here is 0.36. So let's subtract that. 1 minus 0.36 is equal to 0.64, and so the probability that x is greater than or equal to 3 is equal to 0.64. Okay, let's take a look at another one. Go ahead and go to a new page here. Here's another density function. We'll also make this one a triangular one. Let's see if I can draw a straight line here for a change. There. Okay. There's the triangle. All right, and we'll just twist it around. Let's say that the height of this triangle is equal to 1/2. How far out does it have to go? No problem. We know that the area has to be equal to 1. Area is 1/2 base times height. Plug in what we know. We don't know base, we do know height. So that's 1/4 times b. Divide everything by 1/4, and so b is equal to 4. So the base has to be 4. Okay? If we ask what's the probability that x is less than or equal to 2, and this is the question that's been hanging you guys out to dry, because you look at this, you say, well, this is half, so this is half, and obviously they can't be right if you just look at the shape of it. Probability that x is less than 2 is going to be this region of the trapezoid. Again, you can use the complement rule. It's easier to find the area of the triangle than it is the trapezoid. So what we need to do is figure out how high this is. Let me make a mark here. We'll call that h. This one you can do in your head. If you go out 4, you're coming down from a height of 1/2. If you go out half as much, you're going to come down half as much. So what's half of 1/2? This has to be 1/4. It's just a problem with proportions. If you want to set up actual proportions with it, it's no problem. H is to 2 as 1/2 is to 4. Cross multiply. H is equal to 1/4. And you find out the same thing. So the area of this triangle, or this trapezoid I mean, is going to be 1 minus the area of the triangle. So let's figure that out. 1 minus 1/2 times base. Base is 2 because it's 2 units from 2 to 4. Times height. The height of this triangle is 1/4. And so we get 2 times 1/2 is 1. That's a 1/4. 1 minus 1/4 is 3/4. And that's the probability. Okay, let's go for one more. We'll make this one a little tougher. Let's say this one is a house. Looks like that. Let's say it goes out to 10 units. Halfway is where the peak is. That's equal to 5. How tall does that have to be? Okay, you know the area of the triangle has to be 1. Okay, well the base is equal to 10. So 1 equals 1/2 base times height. So 2 is equal to 10h. H is equal to 1/5. And I did that algebra in my head, so you can pause it and take a look at it and make sure it makes sense for you. So this triangle has to be 1/5 of a unit high. Now suppose we're trying to find the probability that x is between 2.5 and 7.5. Okay, if we draw that, it's going to look like this, 2.5 and 7.5. Notice how this is halfway to the middle, and this is halfway from the middle. That means that the triangle, the little triangles we're making here, have to be half as high as the whole triangle. If we're going halfway across, we're going to go halfway up. So this is going to be half of 1/5, which is 1/10. We're trying to find this area right here. I don't want to find the area of that. That's tough. I'd rather find the area of these. And it turns out these are going to be the same because they're the same height and the same width. So all we really have to do is find one of them. So the area of one of those triangles is 1/2 times base times height. And again, you can convert all those to decimals if you want, if that makes you feel better. 1/20 times 2.5. Okay, and I'll go ahead and divide that out. 2.5 divided by 20 is 0.125. So this is 0.125. I've got 2 of the triangles. So the area that I'm interested in the middle is going to be 1 minus 2 times 0.125. So 1 minus 0.25 is equal to 0.75. And so this probability is equal to 0.75. Okay, hope that helps.